morning to all of you. We welcome all of you on behalf of ISTD Gurgaon chapter. So, in the meanwhile, other people are joining. Our chapter chairman, Dr. Raj Singh Antil, is also there with us.
Good morning, everyone. Today's talk is in relation with the series of talk we organize every month or quarterly of 1.5 hour duration. This topic is a very relevant and current topic. I thank the team members who has been given the responsibility, Mr. N.K. Das, Mr. Mukul Jain, Dr. R.K. Yadav, and I also take this opportunity to thank Mr. Ullas Sharma, who is the member of the ISTD Gurgaon chapter, who has taken the lead to deliver today's lecture. I also thank all the members. There are members from other chapters also. Manor Sumil, he is from Reliance Group in the marketing, Siemens Baushar. And I could not see the faces of others. There are many people from other chapters also. I take this opportunity to welcome you all. Now, without taking much time, I ask the team to go ahead to start the session. Thank you.
Thank you, Dr. Antil. And so, once again, welcome on this Saturday morning. So, we have our speaker, Mr. Ullas Sharma. I would like you. Mr. Ullas Sharma has over 3 decades of experience in process excellence and information technology domains. Mr. Ullas has experience in bringing about operational excellence, including business process improvement and IT effectiveness, large-scale program and project management, product management, practice development, consulting, and general management. Mr. Ullas is the founder director of Growth Intellect Consulting. Earlier, he has been in the leadership roles at various organizations, including Accenture, Microland Group, and Hughes Software, which is now known as Ericent. He also had stints at Maruti Suzuki and Mastech. Mr. Ullas was a visiting faculty at School of Inspired Leadership, that is SOIL, Gurugram, for several years. He has extensive international exposure, having worked with clients from 16 countries and interacted with business leaders from several global 1,000 firms across continents. Ullas Sharma ji is a certified Theory of Constraints practitioner in supply chain logistics, certified by TOC International Certificate Organization. He has been an assessor for CII Exim Bank Award for Business Excellence for the Indian equivalent of Malcolm Baldrige Award based on EFQM Business Excellence Model. And even I was surprised to know that Ullas Sharma ji earned a Bachelor of Technology degree from Indian Institute of Technology, Kanpur, and a PGDM from none other than Indian Institute of Management, Kolkata. So, over to you, Mr. Ullas Sharma. The session is yours. Thank you.
Thank you so much, Dr. Jain, for the kind introduction. Also, thanks, Dr. Antil. And good morning to all the participants for joining on the weekend. This is a topic which is obviously, as somebody said, that is currently hot. And the way I actually have prepared the slides is that to provide an overview of this topic, but it's a very vast topic. And my impression was that some students may also join. So I have prepared slides so that people can understand the concepts which relate to artificial intelligence. And of course, there are also, I have included what are the benefits of artificial intelligence, as well as what are some of the pitfalls of artificial intelligence. So let me start. Sorry. I hope the screen is visible to all.
Yes, it is very much visible.
Okay. So let me start with the phrase itself. When we say artificial intelligence, basically there are 2 words here. We are talking about intelligence and artificial, right? And when we talk of intelligence, what do we think of? we think of the human brain, because which is what actually, has all the intelligence, as we know, and it is the most complex, probably the most complex thing, that exists on the universe. It is and we will actually share some, I'll share some data also on about human brain, but this is something highly complex. So intelligence is actually associated with human brain. Now, when we say artificial, what do we mean by that? What we are saying is that we are trying to simulate the intelligence that human brain has by artificial means. And artificial means here is basically computers. So it is not natural intelligence, but it is intelligence which is artificial and which makes use of the computing powers that is available today. Okay. So let me show you how so this is one neuron in a human brain. So if you look at the human brain, it has got about 86 billion neurons, and you can understand how complex it is. And this is one neuron. And I will not go through the entire thing, but just there are two things which are important here. One is there's something called dendrites, which is at the top. You can see these dendrites are the ones which receive signals. Okay, and if you look at what looks like a tail, at the end we have got axon, and axons are the one which transmit signals. So we have something that transmits signals in the brain and something that receives signals. Now this is one neuron. As I said, there are 86 billion neurons, and all of them are connected with each other. So we are talking about 100 trillion connections in the brain. That is how complex this brain is. Now today we have an understanding about the structure of the brain. For example, we are talking about neurons and how they are connected, and little bit of understanding of how it works, but not complete understanding. So therefore it is important to understand that when we are talking about artificial intelligence, we are only trying to simulate how the brain works by different means, not doing the same way that our brain works, because we don't even understand how the brain actually works, though we have a little bit of understanding. But what we have done, as we see later when we talk about artificial networks, that we have tried to simulate the structure of brain somehow, when we talk about machine learning. So we'll talk about it later. Okay. So what is artificial intelligence? So can we teach computers to learn just like human beings do? Therefore, simulate how humans think. So if you look at how a child learns to, you can see a mother teaching bicycle to a child. Now, what the child will do, child will learn by falling a few times. Child is not able to balance initially, but eventually by hit and trial, the child will learn, how to actually bicycle. So, can we do the same thing, with the computers also? That we simulate the learning by hit and trial method, and then we will see this later how we actually do it. So this is one part of it, that is learning. Second thing is the brain is also capable of reasoning, what we actually call logic, right? So the logic is example is if we tell that A is equal to B and B is equal to C, our brain is able to actually conclude that therefore A is equal to C. Now this is called logic. So can we also build logic in computers, which again kind of simulates how human brain works, right? Now, there's another aspect which is very important about human beings. We communicate with each other in human languages, and there are, maybe tens of thousands of languages that exist on Earth, and we are able to learn these languages, and then we understand what somebody else is saying. So there's a branch of computer science which is called natural language processing, or NLP, which actually deals with structure of languages, and how do we make sense out of language. So that is a very important component of this whole artificial intelligence, NLP, or natural language processing. Now, there is something called artificial general intelligence. So this is a concept. What we say is that can computers reach the same level of intelligence that human brain has? And if it can reach that stage, then we would call it artificial general intelligence. As of now, AGI is just a goal. We have not reached that stage, though there are different definitions. And as you can see in the diagram in the next screen, some people actually claim that there are some examples of it, but there are others who say that no, we have not reached that stage yet. Okay, so there are basically we talk about three types of intelligence. One is called artificial narrow intelligence. So artificial narrow intelligence is when we focus a solution on a very narrow aspect. We are saying that we just want to see how we can detect frauds in insurance claims, for example. Right? So that is the artificial narrow intelligence where we are focusing on a very small domain. Artificial general intelligence is when we have reached the level of human brain. That is artificial general intelligence. And there's something called artificial super intelligence, where we are saying if we can exceed the human intelligence, then actually we reach that level of artificial super intelligence. So these are just terms that I thought I will just share with you so that you are aware of it. The intermediate goal of computer scientists is to reach the level of artificial general intelligence, where we can actually reach the level of human brain. Okay. So, if you look at the current state of AI, what are the functions which are still, what are the functions of brain which are not part of AI as of today, right? So, when we talk of AI, see, brain has emotions, brain has common sense, brain has consciousness. Do we have these things in AI today? We don't, right? So therefore, AI is not at the same level as brain. Now, what about the five classical senses? There are five senses that we use. One is a visual, basically ability to see. Auditory, ability to hear. Tactile, if you touch something, we can feel it, right? We can say whether the surface is smooth or rough or whatever. So tactile is basically about touch. Olfactory is basically we can smell. By smell we can tell certain things, right? Our brain can. And then gustatory, basically we can taste. So these are the senses that we have. Do we have AI which incorporates all these? To a large extent, no. Right now, AI actually can only take care of the first two to a limited extent. So we have some visuals. So AI can handle images. It can produce images, which is visual. We also have something called computer vision. Computer vision is basically, can you detect objects? Can you make sense out of those objects? Now, computer vision is something which is used in self-driving cars, for example, right? So it's a very important technology part of artificial intelligence. So we have some level of visual intelligence available today, right? Similarly, auditory, hearing also. So, for example, today there are artificial intelligence systems which can take audio as an input, right? So you can you have maybe use chatbots, right? So chatbots are basically computer programs through which you can talk to a computer. And there are a lot of companies which have actually implemented chatbots to for their customer service. But now there are also options available where you can also talk, right? And you're talking to a computer, you're not talking to a human being. So that kind of capability is currently available. So you can say out of five senses, we have the capability to a limited extent available for two of them, but not all. Okay. So therefore, we come to define what is called a unimodal AI versus multimodal AI. So unimodal AI is basically an artificial intelligence where there's only one type of input is given. So if you look at today, all the kind of systems that we have, most of them, the input is actually text. And so therefore, most of it is unimodal AI, right? And a multimodal AI is where we can have multiple types of inputs. For example, we can have text, video, images, audio. All these can be input as well as output. So that is basically a multimodal AI. Today, if you look at the AI systems, 80-90% of the systems are actually unimodal AI, but we have some multimodal AI systems also, which are recent additions to the AI systems. Now there's a concept of omnimodal AI. Now omnimodal AI is when we actually can take all 5 classic senses as inputs. So as I talked earlier, we can touch, we can smell, and we can also taste. Can we do that? Now, right now, as the computer science stands today, there are some building blocks which are available for these things, but it is not available as part of AI as of now, right? So therefore, we don't have omni-modal AI, though there are some AI systems which call themselves omni-modal, but actually, in fact, they are not. They are actually multimodal AI systems. So you might have seen that some AI systems use O. Now O is for omni-modal, but actually, in reality, they are multi-modal AI systems and not omni-modal AI systems, right? So these are some of the concepts which I thought I'll share. Now, if you look at the computer science, basically intelligent reasoning has been the goal of computer scientists from the very beginning. Can we reason intelligently using computers, right? So if you look at what does it mean, there are two very broad components of this. One part of it is, can computers learn? Can they acquire knowledge? Can they learn? Right? So examples of this would be the logic which is built in programs. So if you look at the computer programs, with any programming language they are using, whether it is Java or C or C Sharp or COBOL or Fortran, these programs actually have logic built in those programs, right? So if you look at any of the business systems, like for example, suppose you are a customer of HDFC Bank or State Bank of India, you can do internet banking. So they have actually developed a program for internet banking where what they have done is all the logic has been put inside a program and we actually access that program. So when we are talking about this, they give very precise instructions to uh, to the program that this is what you should do. So programs can acquire languages by using programming languages. The second way of learning is machine learning, and we will talk about it in detail because machine learning is the hot topic today, and most of the AI that we talk about today actually in past 10 years or so has been about machine learning, and to the extent that a lot of people equate AI with machine learning, but AI is not equal to machine learning. AI is machine learning plus something else, and that is what we need to remember. Uh, so the other part of intelligence is applying knowledge that is learned. So we have already learned something, can we apply it? And that is called automated reasoning. So if you look at the history of computer science, for the first 40 to 50 years, the AI was actually equated with automated reasoning, where we used to tell the computer that this is how you can reason. So we used to give logic to the computer, and computer used to through a program, and computer used to execute the program, and it was all about the logic. Now expert system is a good example of automated reasoning. Now let me take a minute to distinguish between programming languages and expert system. Now when we talk about programming languages, we tell precisely what is to be done, and our program does exactly what logic. So our logic that we gave to program was wrong. Therefore, the result may not be as expected. Or a second reason could be that what we call bugs. Any software program has bugs. Bugs meaning that when you are doing a programming in computer language, then you actually have made some mistakes. So in a programming language, even if you miss out a comma, it can actually change the whole logic. So there are bugs in the software program because of which what the program output may not be as expected. But when you're talking about computer programs, they behave exactly the way what they have been told to do. So that logic is inbuilt. But expert systems actually go slightly further. And the programming language used is also different. Now, we had done programming expert systems in 1995, around that time. And the language used was called Lisp, L-I-S-P. Lisp was the programming language for expert system. Now, what they do is these expert systems also have an ability to learn from the feedback loop, right? So I remember in around early 90s, I used to live in Vasant Kunj, and there was a homeopathic doctor who had come from, I think, US or Australia, one of these countries. And at that time, he had an Apple computer with him. Now, whenever you went to him, you told him the symptoms. He used to actually enter all the symptoms into the computer program that he had for the homeopathic medicine, and the program used to tell the output that this is the problem, and these are the medicines for these symptoms. But what this expert system can do is the doctor actually can override what the expert system has told the doctor, that this is what, are the medicines, or this is the problem. Because sometimes expert system programming may not be perfect, right? Because we have told the logic. So there's an ability to override, and when you override this, then expert system learns the new knowledge, and that knowledge becomes part of the knowledge base of the expert system, right? So one is by overriding this, and other thing is that sometimes expert system may not have a knowledge about a disease. So for example, in this example, so once you give a symptoms, expert system actually doesn't produce any output at all, because that knowledge is not inbuilt in the expert system. Therefore, in that case, a doctor can tell the system that, okay, this is the problem and these are the medicines. Now that knowledge, which was not there as part of the expert system, can be taken by expert system, and then its knowledge base actually increases, by taking these feedback. So expert system is a little bit more sophisticated than a programming language, which do exactly what they have been told to do, right? Now automated reasoning, as I said, was the focus of computer science for first 40 to 50 years. But if you look at last 8 to 10 years, the machine learning or deep learning, they have become very, very important. And you hear about them all the time, right? You hear about, in fact, a lot of times people say AI/ML, artificial intelligence slash machine learning. But as I said, machine learning is more than, AI is more than just machine learning. And there's also deep learning. We'll talk about these concepts a little later, but I just introduce them here. And today there are a lot of people who equate AI with machine learning, which is not correct. So that is something which we need to understand. Now, as far as the research is concerned, the research on both the components has been happening since 1950s, when actually, the computers became very prominent, but machine learning did not pick up. Now, why machine learning did not pick up for 40 to 50 years, and automated reasoning picked up? There's a reason for this. The reason is that machine learning requires huge amount of resources, right? It's a very resource intensive thing, and resources are basically along three dimensions. One is the computing power, right? So we know that computer has what is called a CPU, or central processing unit, right, which actually determines at what speed the computer can process the data, or can work. So that is the speed. This is the brain of the computer, the CPU. So computing power has to be there to be able to do machine learning, because we are talking about huge amount of data, and we will talk about the data very soon. So when we are dealing with huge, humongous amount of data, then we need humongous amount of computing power, which was not available earlier, right, and which is available today. Second is the storage. So I am taking storage space first before memory. Storage space is because we have so much data, you need a place where you can store all this data. So the storage space should be capable of storing all this data. And then we have memory. So how the computer works is it loads programs and data into memory and then executes. So the memory also has to be very powerful and capable. So when we have all these things together, computing power, memory, and storage space, which are very powerful. So first of all, they have to be powerful. There has to be power. Then second thing is the scale. And I'm going to show you an image probably on the next slide, and then we will talk about this. They have to be small enough, right? They can't be too big to handle. And then they have to be cheap. Cheap meaning that they should not be too expensive. If they are too expensive, then again, it becomes extremely difficult to do anything with AI. Today, these things have become relatively, cheaper as well as, uh, as well, cheaper as well as they are more powerful. So that is the current state, and that is why machine learning has taken off in last 8 to 10 years. Now, let me show you this. Now, this is the picture of IBM shipping 5 megabyte hard drive in 1956. Now, you can see that this huge thing is this is a storage space. We are talking about 5 megabyte of hard drive, which is being shipped in 1956, and you can see, how it is being handled. So it is being loaded on an aeroplane, actually on this place, and it will be shipped via aeroplane, right? Today, what is possible is that we can keep 16 gigabyte. Now 1 gigabyte is 1000 megabyte. We can keep a 16 gigabyte, or even bigger than that, kind of a pen drive in our pocket, right? So, and which is about 1 inch. So you can see how the storage space has evolved. First of all, it has shrunk, and then it has become cheaper. So this 5 megabyte drive in 1956 should have costed a lot of money, because you can see what kind of effort is involved in all this, right? But over time, what has happened is that storage space has become, first of all, we can store more, we can store in a very small space. It has shrunk hugely, and then it is much cheaper than what it used to. So, and similar thing is about processing power, and also about the memory, right? And the reason, as I said, that currently we can do machine learning is because all these three things have become cheaper, faster, and affordable, right? Now, the growth of computer science happened since the invention of computers in 1950s. Initially, computer science focus was automation of businesses, right? So, for example, we are talking about, financial accounting. So financial accounting was automated for businesses, payroll. Now payroll was automated. So instead of doing a manual payroll, people started doing payroll through computers. So gradually then supply chain, a lot of other things, manufacturing, all these things were automated. So that was the focus. And this was done through, as I explained you earlier, through the programming languages. So the programs were written in programming languages, and through those programs, we automated a lot of businesses. Over time, the computing power, as I said, grew exponentially. Now, there's something called Moore's law. Moore was the CEO of Intel. You all know Intel. Intel basically develops chips, and Moore's law was basically that the computing power doubles in every 2 years. So, suppose today computing power is X, in 2 years it will become 2x, and in 3 years it will become 4x. In 4 years, it will become 8x. Now you can see there's an exponential growth in computing power, and which is what we have witnessed. And because of which today's computers are very powerful. Now, if you remember the old era, the mainframe computers, which were far less powerful than today's laptops, were actually kept in large rooms, large air-conditioned rooms. They used to be huge things, and they used to be maintained. But today, our laptops are very powerful. And even mobile phones. There's so much power available in mobile phones which can do a lot of things. Okay, so there has been exponential growth in computing power, and which enables us to do a lot of things. Now, after 50s, around 90s, 80s, 90s, internet came, and what happened with internet was that we actually earlier computers used to be standalone. Every computer used to be independent, and people used to work independently on any computer. With internet, the network became the computer. So we actually networked all the computer through a network, and then finally the internet came. So all the machines on the internet can be connected to internet or what we call World Wide Web, right? So basically what it enabled was that it enabled all the computers throughout the world to connect to a common place, which is World Wide Web, which can be accessed using a browser, right? So this actually happened. This was a huge revolution in computers. and which basically actually meant that a lot of data can be accessed which is not on your computer. So if you have World Wide Web, using a World Wide Web, you could actually access data which is stored on a computer in, let's say, in the US or Australia or anywhere in the world, right? And similarly, they can access the data on computers which are, let's say, in India. So World Wide Web enabled that. So which means that there's a lot of data which is available to people using World Wide Web. Then came Web 2.0. Now, Web 2.0, what it did was it actually allowed the users to also produce data and put their data on the World Wide Web. Earlier, the World Wide Web, which was static, which was basically more like, the websites and some data on websites which were created by companies, some information, some knowledge base. But now using Web 2.0 and smartphones, people can create their own content. For example, we are talking about Facebook, we are talking about WhatsApp, we are talking about all these things where we actually the users can generate content and they can put it on the web. So it is available to a lot of people. So which really means that the data explosion happened. The data actually has become, there's a tremendous amount of data which is available worldwide because of all these developments in computer science. First was the internet and web, and then it is a Web 2.0 and smartphone, right? So now you can see that a huge amount of data is available, and we will see some numbers about what kind of data is available worldwide. And then came IoT devices. Now, IoT devices is basically Internet of Things devices like sensors or cameras. Now, they are things which you can actually connect to the internet. So for example, if there's a company which has got some machines in the field, they can actually add some sensors which can sense what is happening with that machine, and those sensors can send the data back to the company, and that can be available on internet or on your internal devices of the company. So again, we are talking about more and more data, right? And as I said earlier, there has been advancement both in terms of hardware and software. So I talked about hardware earlier, but software also should be there to store and manage this huge amount of data. So this actually software has also developed which can manage all this data, right? So there has been advancement in both the places. Now let's take a look at the data. Now before we look at the data, we just want to look at the units which are used to measure data. Now we all know megabyte, right? And we know, I think I am sure all of us know that 1000 megabyte is equal to 1 gigabyte. That we know. But 1000 gigabyte is equal to 1 terabyte. 1000 terabyte is equal to 1 terabyte. 1000 terabyte is equal to 1 exabyte. And 1000 exabyte is equal to 1 zettabyte. Now you can see how big exabyte and zettabytes are, right? This gives you some idea. Now, what is the level of data which has been generated worldwide? By 2005, the amount of data which was generated was 130 exabytes. Okay, so this gives you some idea. It is huge. But what is happening between 2005 and 2010? In 2010, this became 1,200 exabytes. So this is a growth of almost 9 times in about 5 years. What happened between 2010 2015? The data available became from 1,200 exabyte to 7,900 exabyte, which is again a growth of about 6 times in 5 years, right? And between 2015 and 2020, this data became 40,900 exabytes. So again, 6 time increase, or 40,900 exabyte is equal to 40 zettabytes, right? Now, this estimation was done by IDC. IDC is a firm which does a lot of research in computers, and this was sponsored by EMC. Now, EMC is a firm that makes a lot of storage systems. So they sponsored this study to figure out how much data is available. Now, you can see from these numbers that there's a huge amount of data that is available worldwide on different, which is residing on different computers in the world, right? Now, there was another study done, which was done after this, and this is about the future. They predicted that by 2025, the amount of data available will be 175 zettabyte. Now, you can see in 2020, it was 40 zettabyte. that grew by, this would grow about 4.5 times by 2025. So the point here is that there has been an explosion in data. There's a humongous amount of data available. Now, the basic premise of machine learning is that if you have huge amount of data, this data has got some patterns. There are some hidden patterns in the data which we cannot see. But if you have, computer which are, which can handle this data, which have the processing power, memory, storage, then the computer can identify these patterns. And that is the basic premise and the actually the science behind machine learning. Machine learning is based on this basic premise, and we will see more details of this. But the thing is, machine learning is based on pattern matching. Pattern matching, which is different from logic, what was there for automated reasoning, what we talked about in terms of the programming languages or expert systems. So programming language and expert systems use logic. Machine learning use pattern matching. Identify patterns and use those patterns to predict something, right? So that is what machine learning is about. So there's a fundamental difference between these two things, automated reasoning and machine learning, and that is what we should understand. Right? So what is machine learning? So machine learning is basically given the pieces of information. I'm sorry, this is about the automated reasoning. Okay. The automated reasoning is basically given the pieces of information, we can we deduce new knowledge, right? That is basically the automated reasoning. For example, if we say all humans are mortals and we say Socrates is human, therefore Socrates is mortal. So this is basically about logic. That is the automated reasoning, right? An application we talked about could be diagnosis assistant systems, and I already talked about the doctor in Vasant Kunj who used to have this kind of expert system, in early 90s, right? And automated reasoning has a long history, and logic has been the basic thing. Can you provide logic, and can you infer things given, using that logic? So that was the basic premise of automated reasoning. Now, the one of the key developments in logic was development of Boolean logic. Now, people who study computer science, they know that computer science is about 0 and 1, right? And 0 and this 1 is basically about Boolean logic. The whole computers are actually based on zeros and ones. So the data can have two states, 0 and 1. And there's a whole amount of Boolean logic which is built around this. So this is basically modern logic was, Boolean logic was the foundation of computers, you can say. And then we have other things like, set theory and automated theorem proving and all that. And there have been other advances like rule-based systems and other things. So this is basically about kind of a history of, automated reasoning. And as I had mentioned earlier, that for automated reasoning, Lisp is one of the languages which is used to develop artificial intelligence or expert systems using automated learning, which was there in the past. These days the focus is something else. These days the focus is on machine learning. Okay, but just wanted to give you a holistic history of computing. Right? Now, when we come to machine learning, as we have already seen that there's a huge amount of data which is being produced in the interconnected world, right? And the whole premise of machine learning is, can we identify patterns in this vast data which is available to us today, right? So what computer scientists have done is they have come up with statistical techniques. So this whole machine learning is about mathematics and statistics. Please understand that whatever we do in machine learning is mostly about mathematics. We are utilizing the concept of mathematics and statistics to come up with algorithms to identify patterns and learn from those patterns, and then finally use them. And we will see a little bit more detail of this, right? But these techniques obviously require huge amount of computing power, which is available today. And that's why we can do them today. Earlier, we were not able to. Okay, and we had talked about hardware also, which has become faster and cheaper with time. Now there's a company called NVIDIA. I'm sure most of you would have heard of NVIDIA. NVIDIA is a company which actually developed what are called GPUs. So GPUs are graphical processing units. NVIDIA had developed GPUs actually for a different purpose. They had developed GPUs for computer games or video games, right? That is what they were developed GPUs. So this is a very fast hardware which can actually have a huge amount of computing power. But what people realize is that these GPUs actually can be used for artificial intelligence or machine learning. And they started using these GPUs for that purpose. Now, NVIDIA stock skyrocketed in last 2 or 3 years. It just went crazy, and people who had bought those stocks became very, very rich because they realized that Nvidia is a company which is going to win in this AI race. But in last 2 3 months, it has come down also, not so much, but it has corrected, by I think 30 odd percent. And we'll talk about the reasons for that also a little later, right? But the whole premise was if we have fast enough computing power, then we can use that to identify patterns in the large amount of data that is available today on the internet, right? Or on your, or if you're talking about a company, maybe on their own intranet, inside their company also, there's a lot of data available. Right? So face recognition is one example of such applications which rely on identification of patterns, right? So I talked about this earlier also, that AI's time has come because all these things have happened now. Is a convergence of multiple factors, and that is why the ML has become quite hot today. Right? Sorry, this is some. Just hold on for a second. If something is. I'm sorry, there's some. This screen is not moving forward for some reason. Got frozen or something or what? Okay. Sorry, it was not moving earlier. Now it is moving. Okay. Okay. Now the machine learning, I already talked about this. But how does machine learning work? So we have got a data. So let's take a simple example. Instead of talking about all the data which is available on computers, let's talk about an insurance company. Now, insurance company has got last 5 years of uh, claim data, right? They are saying that last 5 years, these are the people who actually made some insurance claims, and can we use that to identify patterns and also predict, for the new data, new claims which come in, which of these claims are genuine and which of them are fraudulent claims, right? So if we have data and we have a positive and negative examples of a concept, in this case, whether the claim is genuine or a fraudulent claim, if we know this, can we actually learn? Can we have a system which can learn these patterns and apply that knowledge to predict in the future whether the claim is fraudulent or claim is genuine? Similarly, we are talking about pictures of cats and dogs. So if we can feed to an artificial intelligence system, let's say 1,000 or maybe 10,000 pictures of cats or different kind of cats, and then similarly huge amount of pictures of dogs, can the system learn, what are the features of cats and what are the features of dogs? And therefore, after that, if we show a new picture of either a cat or dog, the system is able to identify, yes, this is a cat or this is a dog, right? So these are the kind of examples where we use the existing data, which is already there, to learn patterns and use that learning to predict something for the future, right? Uh, Now we will talk about training data a little bit later. I have mentioned it here, but we'll see how actually it actually works. But one of the things which is very important to understand is that this whole machine learning is based on statistical models. So we have input and we have output, right? In between, there's a black box. Now, this black box is nothing but a statistical model or a series of statistical models, right? And these are models. I've given some examples so that people can actually see what actually is happening. though you may not understand statistics, maybe some of you, but a lot of people may not. But just to give you an idea of how actually it works. So there are models like simple linear regression or multiple linear regression or polynomial regression, decision tree, random forest regression. These are the kind of models that computer scientists use to build AI models. Now how does it actually work? What they do is they take data. For example, we talked about claim data for an insurance company, which is available for last 5 years. Right? We take that data as input, and by hit and trial, they will actually learn that which of the models is most suitable to be used as a black box inside this. So, for example, based on past experience or based on experience of other people. So, they for example, suppose they come to a conclusion that polynomial regression is the best model which can be used. So, what they will do is they will take this data. Now, let's assume that there were 10,000 records uh, of claim records for past 5 years, right? As part of this data, they will use for training. So this model has to be trained, which means this model has to be fed this data. Now they might say that okay, 80% of this data, also out of 10,000, 80% means 8,000 records will feed to this model, and so that it can learn the patterns in this data. Now, so let me just give you some example of the data. Now the data is, or data set as it is called. The data may be things like person's name, the first name, last name, address 1, address 2, pin code, city, state, amount of claim, marital status, and stuff like that. That is all data. Now, some of this data may not, when we are doing this process, when you're trying to model this, the model may decide that this data is not making any difference to the output. If I use these inputs, for example, address 1. Now, address 1 may have no bearing at all on whether the claim is fraudulent or not fraudulent. So then they will not use that input. So they are going to prune this data. So we have a lot of fields, what we call fields to start with. They will prune that to identify maybe 4 or 5 key fields which actually can be used to identify a particular pattern. Okay, that is what the AI model will say. And we will use 80, let's say 80 or 75% of this data as a training data to train the model. Now, training meaning that it will read all this data and try to identify a pattern using one of these statistical models, right? And then that knowledge will be stored. After that, what the computer scientists will do is the remaining data, which was let's say 20%. So out of 10,000 records, 2,000 records are still remaining. That data will be used to test the model. Is the model working fine or not? Right? So we have a training data and we have a test data. So we typically divide 80, 20, 75, 25 kind of thing. Most of the data is used to train the model, and a smaller set is used to test whether the model is right, is giving the decent enough. Now that is important, and we'll see this example. Machine learning may not, and it may seldom give you perfect output. Okay, it will give you an output which may be good enough for our use, and we will talk a little bit more about this later. What may happen is if we are not happy with the output, we can actually refine the model, and there are techniques for doing this. These statistical models can be refined so that we actually have a reasonable output, not perfect, but a reasonable output. So input, a model which is a black box, and an output. And we train the model using training data, which is the past data available to us. And then we also test it using the test data. Now, after the model is ready, we are saying now the output looks decent enough. Then we will use this model to apply on the new databases. So if any new claim comes, that claim will be passed through this model, and then model will tell whether this is a fraudulent claim or it is a genuine claim. So that will be the output of this model. Okay, so this is conceptually how machine learning works, right? And there are different kinds of learning like supervised learning, unsupervised learning, semi-supervised learning. So just to tell you very briefly, supervised learning is this example. Like we talked about the claim data. Here we are the data we are giving to the model is basically we are saying that this field is name, this field is address, this field is claim amount, this field is zip code and all that. So we are actually tagging the data. It is being tagged. That is supervised learning. So the model knows that this data means this. But there can also be unsupervised learning. Now, when we talk about LLMs or large language models later on, uh, you know, we can also have the AI system learn from without giving them any input at all. We are saying this is the data. You take this input and identify patterns yourself in this data. That is basically unsupervised learning. And semi-supervised learning is something in between, which is more practical thing. Because unsupervised learning, the data, the system may be able to identify patterns, but how to use them, it may not. So some kind of human intervention may be required after the unsupervised learning to tag certain things. Okay, and we will talk a little bit more about this later. Yeah. And even the techniques which are used in machine learning, they have a long history. They have been being used as far back as 18th century, right? So let's move to the next one. Okay, now this is the example I had given you. In machine learning, uh, these are the images of dogs on the top, and then we have the images of cats at the bottom. If we can feed all of them to an AI model and use the appropriate statistical model as the black box, the model can identify what are the features of dogs versus what are the features of cats. And if we show a new picture of a dog or cat, it can possibly predict with reasonable accuracy. And I am emphasizing with reasonable accuracy whether the new picture is that of a dog or a cat, right? And we already talked about the training data and test data and how we can refine the output based on the feedback, right? When we receive the feedback. Now, this is basically the process which I talked about for the machine learning. So you formulate the problem or the business case, and if you consider the example for the insurance company, it is about how do we identify fraudulent claims, among all the claims which we are receiving. Then you collect as much of the past data as possible. You prepare and analyze. So a lot of times the data has to be cleaned because data may be imperfect, the fields are missing, or there may be other problems in data. That has to be done. Then you identify what is the correct algorithm. This algorithm is nothing but a statistical function, as I talked about earlier. Then you train the machine learning model uh, from, let's say, 80% or 75% of the data. Then you test the model with the remaining data, which is already existing. Then you evaluate, is the model working fine? If it is not working fine, you see how we can improve this model. Sometimes this could mean that we actually junk the earlier statistical model and we say this model is not working at all. So let's try a new model. And we can do sometimes, AI scientists do that also. And finally, when we think that the output is reasonable, then we publish the model and then start using it. So that is the whole cycle of machine learning, how actually it happens. Now, we have something called artificial neural network, right? So we had talked about the neurons in the brain, and that time I told you that what we do in machine learning is simulated. We are trying to simulate how brain works, not exactly the way brain works, but we try to actually use some of the concepts from the brain, right? And as I told you, in the brain there are a huge number of billions of neurons which talk to each other, and then basically the output is an interaction of these neurons. So we actually in artificial neural network we use that concept of neurons being connected to each other. So here what we are saying is that we have input layer which is in yellow, we have output layer which is in green, which is the output of our IO model, and in between we have these statistical models. Now we can have more than one layer of this. If it is a single layer, then that is being shown on the left. But if you have multiple layers, right in the for example on the right side, then if the number of layers is 3 or more, then it is called a deep learning. So deep learning is when the number of layers in an artificial neural network is either 3 or more than 3. If it is 2 or less, then it is not deep learning. That is simple machine learning. So that is the difference between machine learning and deep learning, because I'm sure that you have learned of both the terms. But this is how we try to simulate, and we have statistical models. Now you can see on the right hand side, we have used multiple statistical models. Now here also we are showing 3, but in very complex systems there could be hundreds or even 1,000 or more than 1,000 layers. So it can be so complex when you're talking about huge data. So actually it can become very complex, but we are taking some simple examples to understand basic concepts of how machine learning works. Right? Now, this is I told about the statistical models, but this is just to give you an idea. Now, this is one problem that we are trying to identify. If you look at there are two axes, X and Y, and we have two different kind of data inputs. One input maybe in green. Green maybe, for example, if you take the same example of the insurance claims, green may be the data which says that the claim is authentic. The red, which is with cross, says that this claim is not authentic. This is a fraudulent claim. Suppose this is the data. We have plotted this data on XY axis. Now, what will be the function which can tell us that, how do we identify whether a claim is fraudulent or not? Now, in this example, there are two different ways in which we can do it. You have this blue curve that you can see, which is trying to separate the correct ones from the wrong ones, right? You can see that. And we can do it in two different ways. Now, this is basically the function. When we talk about statistical function, people who are very good at statistics, they actually can identify that this function will be approximately similar to the function that we have drawn here in blue, right? And that is how it works. So the function that we are using will be will have the nature of that function will be, if we draw it, it will be similar to the blue curve that we have drawn. So that is how we choose which statistical function is relevant. Now, this is a very simple example. In more complex example, obviously the things get more complex, and this function actually becomes what we call the hidden layer, which is shown on the bottom. So we have input layer where we are getting various inputs, and we have a hidden layer which are basically nothing but these statistical functions, and then we have the output layer where we actually get the output of the machine learning model. Okay, so this is just to conceptually to show how this works, because it is very difficult to visualize how a statistical function can actually give these results by identifying patterns. This is how actually it does. But this is a very simple example. It's a slightly more complex example here. Again, we have data which we have plotted on X and Y axis, and there are again things which are the data which show that the claim is genuine, and data which show that the claim is fraudulent. Now you can see here the curve here is more complex, right? You can see in blue. Now what may happen here is that you may have to use two functions here instead of one function, because there may not be one function which actually can simulate this. So we actually may have two functions, and those two functions may become two hidden layers. This is another example of how it actually works in practice. Now here we are showing only two dimensions, X and Y. Actually in practice there can be multiple dimensions, 3 dimensions, 4 dimensions, and it can become hugely complex. And even to do this, you use computers. So use computers to arrive at an AI model, or arrive at what is the most appropriate statistical function to use for this kind of a problem. Now, this is actually a very important thing when you deploy a machine learning model. You actually try to plot what is called the confusion matrix. And how is it important? I told you that these systems will not give you 100% perfect output. They will give you output which may be reasonable for our use. Now, in this case, suppose there's a system which tries to detect whether a tumor is malignant or benign, right? So this is an application in the medical science. Now looking at an image, say an MRI or any other image, which normally the doctors do. Uh, uh, the the AI system is trying to identify um, whether the system is whether the tumor is benign or malignant. Now, obviously, this system has been trained on the past data, past images, and therefore now it is trying to predict for the new data. Now, here we have taken an example of 10 lakh, cases. Now, suppose this is the output of the test data. I talked about the training data and test data. Now we are testing it on 10 lakh, 10 lakh instances of test data. Now, what is happening is there's something called now on the x-axis we are plotting what was the actual result, whether this tumor was malignant or not. Actually, so one one axis will show, one column will show malignant tumors and other column will show the benign tumors, right? On the y-axis we have what are called the predicted result, what AI model has told us whether the tumor is benign or it is malignant. Now here again, you can see this is a 2 by 2 matrix. Now if we look at the first cell here, the first cell is basically the actual result was malignant, and AI is also saying that it is actually malignant. So those are 990 cases, right? So here it is green because AI is predicting exactly what actual result was. So there's no problem at all. Similarly, if we look at the bottom right cell, here the AI is predicting that this is a benign case. There's no cancer here, and AI is also saying the same thing. So actual result and AI result they match. So these are the green cells, right? Where basically both of them match. Now the problem is with the red cells. The actual result was that it was actually a benign tumor, but the AI is saying no, it is malignant. That is 9,990 such cases. Now this could be a problem because we are saying that it is malignant tumor, and we may start treatment based on that, but actually it is benign. The other one on the left bottom corner, there are 10 cases where actually there was a malignant tumor, but AI could not predict. AI said, no, it is benign. Now, these are the red cells are the problem cells, right? Now, this is basically where the judgment comes. We are saying that in out of 10 lakh cases, in 9 lakh 90,000 cases, AI can predict accurately whether the tumor is benign or malignant. But in 1% cases, it is not able to predict correctly. Now, should we use AI, and if we use it, how do we use it? Right? Currently, in the current state of affairs, mostly AI is being used as a supplementary input, and mainly with the junior doctors. So the junior doctors which are trying to look at those images, this is a supplementary information that AI is providing, so that they have one more input. And sometimes if they feel that AI input is different from what they thought, maybe they can go to their seniors and try to confirm whether their conclusion is correct or not. Now this is an example from the medical field. Now suppose we change this example and say this is from the insurance claim frauds, right? Now the malignant tumor, instead of that we say these are the genuine claims. Malignant means these are the fraudulent claims, and the benign tumor, we say these are the genuine claims. Now the situation is different. Now we are saying that AI model can predict with 99% accuracy whether the claim is genuine or fraudulent, right? Looking at this confusion matrix. But in 1% cases, it is not able to predict. Now look at those 1% cases. Now there are two such cases. One is called a false positive and other is called a false negative, right? The false positive is basically when our model says that it is benign, but actually it was malignant, right? And the false negative is the other way. So if you look at the claims, fraudulent claims which were not detected by AI, which will be number 10. 10 claims which were actually fraudulent, but they will not be detected by AI, which is out of 10 lakh claims. So the business may say that it is okay, we can deal with this because this is very, very small and this is cost of doing business. But we are saving a lot of money and we are able to settle claims much faster for our customers, and customers are happy, they will give us more business. So this is okay. Now, what about the cases where the model says that this claim actually is fraudulent, but it was not fraudulent? Those cases we can say that all these cases will actually have human intervention. So the insurance companies may take a stand that we will use AI model, but there will be human intervention in those cases where the model says that this is a fraudulent claim. But these are very small. Out of 10 lakh cases, only about 10,000 cases are being flagged as fraudulent, and we will have human intervention also here, so we can double verify whether it is correct or not. So that is how. So the insurance company may decide, though this AI model is not giving us perfect result, but this is good enough for our business because it is saving us a lot of time, effort, money, and it is providing us better customer service. And we can deal with 10 cases out of 10 lakh where there was a fraudulent case which we paid out, and it's okay. There's no issue, right? So this basically gives you an idea of how AI can be used in business even when the results are not perfect, and that is important to understand, right? Now we talk about deep learning. As I told you, deep learning is where the artificial neural network is very complex. It has lots of layers, at least three, but it can be hundreds or thousands of layers. So it can become very, very complex. Right now, deep learning is being used for problems which are complex. For example, can we identify image? Can we identify a face? Can we detect tumors? Or even to play games, right? So there are a lot of such complex decisions where deep learning is used because simple systems can be used for simple things. For example, fraudulent claim detection. But when we go to more complex problems, then we require deep learning. So, and deep learning is all about using more complex AI system to solve more complex problems. That is what deep learning is. And I had shown you a picture earlier. This is basically a diagram of a deep neural network where you have three or more hidden layers. Hidden layers which are black boxes, which are basically statistical models, which are not visible to us. We already know about the input and output. Okay. Now you must have heard about large language models or generative AI in recent times, right? So this all became basically buzzword when Chat GPT was launched. Right? Now, before we go to LLMs and generative AI, let's understand something else. We have something called foundation models. Now, these are the models which are used, which are built by using huge amount of data. For example, we might say all the data that is available in the world. Let's take that as an input and build a model where the model is using unsupervised learning. Unsupervised, which means that no human intervention is happening, and the model is trying to identify patterns in this data. This huge amount of data which is available. And this could be just text or images or whatever. So let's take an example. You are using only text. So all the text that is available in the world, wherever on any computer, we actually use that as an input and ask our model to understand the patterns which are available in this data. through unsupervised learning. So these are the foundation models. But remember that even in foundation models, later on, after unsupervised learning, some human intervention is required. Because just to give you an example, suppose foundation model, we feed all the poems or all the novels which are existing today, right, anywhere on the internet. Now, foundation model will learn that all these poems look similar. So there's a pattern in these poems. For example, they are ending with a rhyming thing. So they can identify these patterns using statistical models. But someone has to tell them that these are poems, right? That has to be told. Because when I'm interacting with a model and I tell them, can you write a poem? So the foundation model should know what are the poems from this huge amount of data which it has taken as input. Similarly, what is a novel? And so human intervention is required at the end to tag certain things. So the tagging happens after the unsupervised learning has happened, and uh, the AI system has already created different classes of data. And we can tell, okay, out of these classes, this class is basically poems, these are novels, and this is this, and this is that, right? So that kind of intervention happens at a later stage. So as I said earlier, foundation models are trained on a broad set of unlabeled data that can be used for different tasks with minimal fine-tuning. Some fine-tuning is required, but it is not, it is very different. Suppose we had to take this same amount of data as supervised learning, then the amount of effort is huge. I mean, you can't even imagine what kind of and number of people required. But we do it after the unsupervised learning to tag certain things where we actually make the data make sense to the model, right? Now, why they are called foundation models? Because once we have done this, these become foundation for many applications which can be built on top of this foundation model. And why foundation model? So let's understand why we are doing this. Now, it is not possible for any even large organizations, unless it is very, very big, to actually deploy the kind of resources which are required to handle this data. Huge amount of computing powers are required, huge amount of memory, huge amount of data storage space is required to handle the zettabytes of data that we have available today, right? And that is done by the organizations which actually build these models. So one such organization is OpenAI. Now, OpenAI is basically is an organization where Microsoft has 49% of the shareholding, and remaining shares of this organization is held by various other people, including some PE companies, right? So this is an independent kind of organization which has built GPT 3 and 4, which we'll talk about later, right? So it is done once. Now, once this foundation model is built, this model can be used by other organizations to fine tune it for their own use, right? And as I was Google is another company which has built foundation levels, foundation models. Now, to give you an idea of the kind of resources that they use, the electricity which is used by companies like Google, Microsoft, and some of these companies is actually more than the electricity which is used by some countries. Some countries in South America, Africa, and all, which are small and medium-sized countries. So they use so much electricity, which is a whole country uses it, even more than that. So that is the kind of computing resources that are required here, right? Now we have heard of large language models. Large language models are basically one type of foundation models which use the text as an input, and they also use NLP, what I talked about earlier, natural language processing, to understand this content, and they can perform wide range of tasks. So LLMs deal with text and languages. That is what the LLMs are. And generative AI is also is kind of foundation model which can generate some original output given an input. So suppose I tell the model, can you write a poem? So it can write a poem. If I tell them, can you summarize this document? It can summarize the document. If I tell the model, can you write a new marketing message? It can write a new marketing message. So generative AI is a type of foundation model which can create original content. And or even software code. It can even generate some kind of a code. So that is these terms are used very often. So I thought I'll just talk about, explain what they mean. Now look at the development of AI. What have been the major success of AI? The first major success of AI, which was actually became, uh, uh, which came in the news, was when a computer which was created by IBM, it beat Gary Kasparov. Now, Gary Kasparov, as you know, was the world champion in chess, and it played a game of chess with a computer called Deep Blue, which was an IBM computer. Now, first time when they played the game, in the first game, actually Gary Kasparov beat the IBM computer, and I think his score was 4-2. So Gary Kasparov won by 4-2. But the next game that they played after 1.5 years, then the Deep Blue, which is an IBM computer, actually could beat Gary Kasparov, and the score was I think 3.5 to 2.5, right? So then obviously it made a lot of it made a huge amount of news and hype that time, that AI can actually even beat the world champion. Similarly, in 2011, this happened. There's a game called Jeopardy, which is quite popular in the US. And in this game, the host will ask a number of questions, and anybody can answer. So they have to press a buzzer. Whoever presses the buzzer first can answer. And these questions are, and there was a computer which was developed again by IBM, and that computer played the game with the Jeopardy champion. So the guy, the can here is basically the champion of Jeopardy. Then Jeopardy is basically a program which is broadcast on TV every week, right? So in that year, he was the guy who was the final winner of Jeopardy, and he played Jeopardy with a computer which was developed by IBM, and the computer actually could beat Watson is the name of the computer. It could beat the Jeopardy champion. So this was again major success of AI, and there have been other games, where also the computer has beat the champions. And other example is the self-driving car. Now, self-driving car, have been introduced in the US, and though there are still challenges, but how can a car drive itself? Now, that itself is a huge jump in terms of the innovation. That is also a major success of AI. Now, but at the same time, there have been unmet expectations of AI. Now, there has been a hype, about AI, and AI has not been able to meet the expectation sometimes. Now, there's something called a Turing test. What is a Turing test? Turing test is that you have two rooms. In one room, you have a human being, and in another room, you have the computer. And you ask the same kind of a question to a human being in one room and computer in the other room. If the computer does better than the human being, that obviously the AI has beaten the human being. If not, then human beings then AI is not as good as the human. So that is a Turing test. This is a test of how good the AI is, and that has been done multiple times. And the AI a lot of times has failed in the past, right? Um, have we realized a truly intelligent system? No. The answer is no, because the machines still lack the common sense and a lot of other things. So we have common sense as human beings, machines don't. So we actually have not reached that level of intelligence where we can say that the intelligence of machines is same at the same level as the level of intelligence of a human being. That is another thing which is not, though people had predicted that by this year this will happen, but actually it has not happened. So that is also the unmet expectation of AI. There was a huge hype about AI when the perceptron was discovered. This happened actually in around 1960s. So perceptron is something similar to what I had shown you as the artificial neural network. So that was discovered way back in 1960s, and there was a huge expectation that now AI will come into being, but actually it didn't happen in 60s and 70s. And therefore, what is called AI winter, a lot of things didn't happen in AI for a very, very long time. You know? And they started happening only when our the computing power, the memory, and the hard disk became a lot more powerful. Now we come to what is the promise of AI for humanity. Now, McKinsey Global Institute actually had done a study, and they came up with 160 use cases, which means there are 160 such domains where AI can be used to for the welfare of humanity. Now, I have taken the humanity angle. Of course, AI can do a lot for business, and that is a separate topic. But this is basically for the humanity. Now, if you look at these examples, now they have tried to plug these 160 cases into certain groups. Now, these groups are, for example, security and justice, right? Crisis response, economic empowerment, education, environment, right? Equality and inclusion. So, in all these kind of domains, there are a lot of use cases, the things which can be done by using AI. This is the promise of AI for what we talk about, how AI can be used for bettering human life. Now, I will take some very specific examples. Navigating the aftermath of Hurricane Harvey. Now, there was a hurricane in the US called Hurricane Harvey, and after the hurricane was over, it was a very, very powerful hurricane. Then a lot of roads were damaged and a lot of things happened. So Facebook, AI researcher, they use the satellite images to predict where are the roads broken, by using those images and using an AI model, which could predict based on the past data. And with 88% accuracy, they could predict that these are the roads which are broken. So the help could be, sent to those places faster to build those roads. So this is one example where AI has been used for humanity. Similarly, reduce poaching in wildlife parks in Africa. Now, in Africa, there are a lot of wildlife parks, and poaching is a very common problem. Now, what they have done is they have actually put a lot of hidden cameras, in different places, and using AI models, they can identify whether a person who is being shown somewhere is a poacher, and then an alert can be sent to police, and then they can come and catch the poacher. Similarly, there are a lot of other examples. Now, in the interest of time, I will just fast forward because the time they have already taken a lot of time. But just wanted to show you that there are a lot of domains where AI can be used for bettering human life. And similarly, there are a lot of limitations of machine learning. For example, I talked about the huge amount of resources which are required, and even for a narrow application, you have to train this, and there are a lot of other things. So I will probably, move forward because we already consumed a lot of time. There are a few other things which I wanted to show you. So among the pitfalls, I would like
Professor Ullas,
yes.
this is Dr. Bharat. I just want to tell you that I'm enjoying your talk so much that I think you should go on for irrespective of the time. So it is my freedom to you. I think this is an awesome talk. It is giving such a nice overview. I am amazed at the simplicity with which you are presenting this complicated topic. So please, from my side, you can take more time, no problem at all. But please finish whatever you have.
Thank you so much. I am actually looking at Dr. Mukul Jain, who might interrupt me any time to tell me that I have already overshot the time.
We'll have question and answer sessions also, no? Right. We'll have question and answer.
But see, what I will do is, Mr. Bharat, I will definitely cover the more important parts because, but there are few other things which probably may not be, so important. But this slide is important, so I will cover. So I already talked about the computational resources, but one thing in AI models is about the bias, and which is very, very important. See, what we have done is we have actually trained these models on the amount of data that is available. Now, this data which is available may have a lot of biases. For example, if you look at the data which is available on internet, now there's a lot of data where people have given their opinions. Now opinions are not facts, right? People give opinions about everything and anything, right? So those things also are part of the training data. Now if the model has learned those things, that actually can create a bias, right? So we have to be very conscious about this, and bias is a very big problem in the AI systems today, right? And biases can also come because of other reasons. For example, if you're talking about an organization where you are training data, there may be biases in that organization itself, right? There may be gender bias, or there can be other kind of biases, and those biases, if they are in the data, then actually it may come in the model also. So just to give you a practical example, suppose we are talking about a banking application which gives a loan, right? And then if you think that in the past people were biased against people belonging to, let's say, a poor families, just an example, or people belonging to certain, people living in certain areas, where people think that if you give loans to them, the money will not come back. Now those biases actually will become part of the model. So therefore, when a model recommends whether a person should be given a loan or not, that output is going to be biased, right? So we have to be very conscious about this. And which is a similar thing is a lack of explainability and interpretability. Since we are talking about data where we are looking at pattern matching, so this whole concept is based on pattern matching and not based on logic. I explained that earlier. So you can't explain how the model is working. So again, giving the example of claim, suppose a claim is not passed by the AI model. You say this claim is a fraudulent claim. You can't explain how the AI model arrived at that conclusion, because it is a statistical model, right? So it is again, so those are the things. Now, security and privacy concerns, we all understand. These are important because, so on the privacy concern, let me tell you that there's a novelist which actually filed a lawsuit against one of the models, a company which developed a model, where, the input was taken as all the novels of this author. And what somebody did was they actually created new novels based on this model, which use a similar style, right? And they started selling these models on Amazon. Now you can imagine. So obviously this novel was, quite cheesed off, and they filed a suit. So then the obviously Amazon made this correction, and even the model excluded some of those things from input data. So privacy concerns are similar to security. Things can be hacked, right? So some of those things are there. Other very important thing is the environmental impact. I told you that the electricity which is generated by is more than the electricity consumed. Not electricity consumed by some of these companies like also a concern for this. Then there's an ethical dilemma. No, I will not talk about ethical dilemma here because I want to actually show you a diagram here, right? Now, ethical dilemma is we are talking about the self-driving cars. Now, the first ethical dilemma, for suppose there are two people who are crossing all of a sudden they appear. There's a curve and they appear in front of the car, which the car could not see earlier. And a car is being driven at a certain speed, right? So one ethical dilemma is, should it apply the brakes? Now, if it has to apply brakes to save these people, the brakes have to apply it so hard that the people who are in the car, they may get hurt or they may even get killed, because it is being driven at, let's say, 100 miles per hour, right? So that is one ethical dilemma. Who should it save? Should it save the occupants of the car, or should it save the people who are on the road, right? Now, within this, there's another ethical dilemma. Maybe the car can swerve. Now in this example, there's an old lady and a child who are trying to cross the road. Now, if it tries to swerve, it may actually kill one of them, either the child or the old lady. Now, the ethical dilemma is who should be killed and who should be saved. Now, how can an AI system decide, who should be killed and who should be saved? safe. So that is the ethical dilemma that is there with AI, and there are a lot of such examples. So I just wanted to give you one example just to bring out this point. Now, another important point is the hallucination. Hallucination is when the AI model gives you wrong answer. And I told you that AI systems are not perfect. So, for example, when you're talking about a large language model like ChatGPT, and you ask the ChatGPT a question and it gives you wrong answer, that is called hallucination. Because hallucination is that the answer is not what it should be. And there are many reasons. And one of the reasons is that the data itself can be incorrect, right? So we need to watch out for hallucination also. The last one is important. There's Quora here, right? So Quora is a thing which is, or Reddit, which is about the opinions of people. If that has been part of input, then there are a lot of opinions which have become part of the training data. But then if the output gives you that answer which was there in Quora, that answer may be wrong. So again, the hallucination is an they distinguish between the physical objects and human beings and all that, right? And this is a stop sign. In the US, we have these signs where the cars are supposed to stop, right? Now, if we actually paste some certain things on that stop sign, like here you can see somebody has pasted something, then it can confuse the AI model and it may not stop because it may not identify that as actually as the stop sign, right? So you can fool the system by doing some of these things, and which is again a drawback of the current state of AI today. Generally, I'm not going into this, but you can actually add some noise to a picture. So, for example, on the left you have a panda, and which the AI system could identify with 57% confidence. But when you add some noise to it, the same AI system is telling no, it is a gibbon. Right? So the AI system can be confused by actually adding noise or doing something weird. So that is a drawback, which is a limitation of the AI systems today. Current trends, the reality check. Initially, there was a lot of hype just 2 years back, and because of that, as I told you, Nvidia stock went up by a huge amount. People made a lot of money, but in last 2 or 3 months, Nvidia stock actually has corrected because now people have realized that at least the business use of AI, has not happened as per the expectations. So now the expectations are more realistic, and therefore the Nvidia stock has corrected because there was a lot of hype, and that hype has not materialized, right? The other thing is that I talked about the multimodal AI, where you can actually have different kinds of inputs apart from text. So text, image, speech, and all. Now there's a lot of emphasis on video. Can we take video as an input and work on that? So a lot of research is going on in this area. Explainable AI, there's a lot of demand from governments and other organizations that you should be able to explain how the AI arrived at a decision. Now, it is a very tough domain. Some research is happening, but it is not easy thing, right? And similarly, other things we talked about. Quantum AI is important. Quantum AI is that we are trying to make use of quantum computing and see can we build AI models based on quantum computing. Quantum computing is based on quantum mechanics, and it is much more powerful. So can we use that? So then we will. Okay, now I just wanted to share some of the popular AI tools which are available today. You might have used some of these already, but just a list. And for example, for text generation, you have OpenAI has GPT-3, GPT 3.5, and GPT-4. Some of them are free, some of them are you have to pay for. For example, OpenAI started when they started, it was free, but now GPT Plus is actually paid, and GPT they are not taking any new subscribers. Now, right? Google has something called Gemini. Microsoft has something called Copilot. That is for the text. For image, we have something called Stable Diffusion, which is an open source thing. OpenAI has something called DAL E3, right? We have something for video creation, Lumen 5, Gen 1, and for code generation. The software companies actually can deploy some of these AI systems to generate code. Now, this code is not perfect. We still need programmers, but at least it gives them a starting point. So they will generate some code which programmers have to actually review and modify. So a lot of things are happening. These are some more AI tools available for music and art generation, for marketing material. So there's something called Luca, where you can actually generate a new logo for your organization and do a lot of other things, right? So you can maybe try out some of these things which are available. So that's it. Thank you. Thank you very much for your time. I'm sorry. I think I took a lot of time to.
Oh, thank you so much. Thank you so much, Mr. Ullas. It was really a very exciting session, and single-handedly, you took almost more than 1.5 hours. So very informative session, and I wish that some students would be attending this session. It would be very useful for them, especially engineering students. So the floor is now open for question and answers. Those who want to speak, to ask any question, should keep their questions very brief. And you can unmute yourself and you can ask your question, or otherwise you can also type on the chat box.
So this is Bakul.
Yeah, hi, Bakul.
Yeah, so supposing like we want to use, first of all, where from we can get a training on all these tools. This is just an introductory session. And
Yes.
second is how to apply to my business. If at all I come with a business problem,
Yes.
like would you be able to help, or what is the way forward we can? So these are two quick questions I have. I should
Okay,
have
so
asked only
as
one
far
at a
as
time. Yeah, go ahead.
no, I'm sorry, I just interrupted you. Yes, for as far as the tools are concerned, I have actually shared tools which are more, for fun kind of a thing. Though some of them can be used for business also. There are separate set of tools which are available for more for business. But here also, for example, for marketing material like Luca can be used for marketing material, and similarly, even the other tools can be used for business. Like LLMs, for example, right? So you want to summarize something, or you want to create a email, that can be done by tools, right? Now, your other question was, where can we, suppose you have a business problem, how do we proceed? Now, you can actually connect with me, or there are a lot of other people who are available. And I had shown you actually a slide. Unfortunately, the system is again getting some problem. Sorry. I'm so sorry. It's not going back, but there was I think it's going back now. So let me just show you that slide. Just give me a second. This one, right? So this is what you develop the system. So first thing is to identify the problem or the business case, what exactly you're trying to do, and then after that there will be people who are so as far as I am concerned, we can actually help you in the managing it, providing advice at the management level. But there will be a separate set of people who can actually develop AI models, and those people are different. They are basically part of the technology companies which do this, which and they are separate set of people. So we can only help you in terms of planning and executing, but to develop the actual model, there are different set of people. I can introduce you to some if you're interested.
ISTD Gurugram chapter itself, and he
Okay.
is a very active member.
Oh, wow. Then it would be a lot easy for me to connect.
Yeah,
Yes.
actually, Bakul, we have been together in some meetings. Maybe you didn't recognize me, but
Yeah,
actually, we
yeah,
have
yeah.
been together in some meetings. Yeah.
Yeah, Mr.
Yeah,
Ullas,
yeah,
I am
yeah.
Prerak
Yeah,
Desai.
thank
I
you
am
so
Prerak Desai from Vadodara.
Yes.
Yeah. Hi. Hi. Prerak.
Accident session. I think the data information you have is I think exceeding 100 zettabyte. that one I can tell you, and very relevant, very relevant. But only my only problem is I'm an ordinary HR. Each 50
It is
to
not
Professor,
possible.
Professor
You
Ullas,
have
one
MTech
second, please, one
only
second.
for-
I completely disagree,
Sure.
totally and completely. On the other hand, I thought that it was very good for high school students on the initial few slides.
Okay.
Yeah.
That means I need to go back to school.
Yeah, because you know, in a school they are teaching so much nowadays. And
Now
already covered in high schools.
yeah.
Yes, yes, we'll do that.
Okay.
Okay,
Yeah.
especially if they are
Sir,
having
Yeah,
sir,
yeah.
there are students from Susant University, Gurgaon. There are, sir. Yes, sir.
okay, that's
Okay,
great.
very good. Any other question, please?
Rajendra ji, we are also students.
Thank you, sir. Thank you so much, sir. Dean, sir, you are so humble.
If there are any other questions, please do ask.
If we are planning a follow-up to this as AI in HR, I would also like to contribute some in that one.
Okay, sure.
Sure. You are most welcome. You are from which chapter, Mr. Bharat?
I am actually at, yes, Rajendra ji.
Sir is our Honorable Dean, School of Engineering and Technology, Dr. Bharat.
Oh, I see.
And
Very
he's
good,
from
sir. Very
IIS
good.
Bangalore and PhD from California University, USA, sir. So,
Very nice.
very
Great.
learned person and rooted to earth, very unassuming persona, sir. Yes, sir.
Welcome, sir. Welcome.
Today I got this Zoom meeting invitation from Professor Rajendra, and you know, I've never ever, whatever he says, I have to do that. So
Thank you,
I
sir.
have to
Thank you
come,
so
and
much.
this was such a, and I'm so happy at this joining this invitation. That was such an awesome talk. That's why I know that this talk would have been so useful for our undergrad, BTech, and BCA students, because this
Share
gives
the
such
we
nice
can share the
overview.
recording, sir. We can share the recording. The session has been recorded, and we can share this recording.
That will be awesome. If you
Yes.
can please share it to with Rajendra, Dr.
Yes, sir.
Rajendra, so we will. That will be awesome.
Absolutely, sir.
And may I request honorable chairman, sir, and honorable speaker, learned speaker, to kindly consent for our students for a session at the campus of the university, please.
Yeah, sure. We can look at that.
Yeah, I
Thank
think
you, sir.
we'll open a chapter in your Susant University. I'd love to be form a group of there and we'll organize whatever requirement is there. No issue. Thank
We
you.
start, sir. Thank
Professor
you, sir.
Professor Rajendra, can we not do
Sir,
like this, that we can open, like we can have an inaugural session where we can invite the members and open up a new chapter there. So that way we can have our talk also, as well as opening of this chapter also.
Sure, sir.
Definitely,
Sure.
sir.
Looking forward, sir. We'll do that. Sir.
Definitely.
Thank you, sir.
We have,
So,
we have scheme of student chapters for full of the duration of the course of 2 years or 3 years, whatever it may be. The student can pay only 250 rupees, and then they will be getting identity card from the Indian Society for Training and Development, and they will be invited free of cost. You know, almost all the programs conducted by the ISTD. So this is, I think we already have 2 chapters. One is already we have with the Kumar Mangalam University, then another institute in Sector 32. So we welcome that. I think we can associate it that with a good gesture on the part of the Dean Susant University. Thank you very much.
Thank you, sir. Thank you, sir.
No, I think that is very, very reasonable. I think there will definitely be few students who will join.
Sir, now in the chat box, I am seeing there is a request from one of our members, Mr. Praveen Garg. He has requested the speaker to show the first slide. So after that, we will have the vote of thanks. Ullas sir, if it is possible to you, Mr. Praveen Garg, our member, has requested to you to show the first slide of your. If it is possible, then
Yeah, I'll just do it. Just give me a second.
yes, sir.
You're talking about which slide?
I think this is the main slide. I think the first slide where you have shown the brain. I think the third slide rather. This is what I think Mr. Praveen Garg wanted. Your third slide, sir. This one. Yeah.
This one?
I think, yeah, this he wanted to see.
Next one.
Next
Right.
one.
Right, sir. Right. Now, keeping in view the importance of the time, so I would request our esteemed member, and he's the treasurer of ISTD Gurugram chapter, Dr. Session.
So much, Honorable Chairman, sir, who has today, Sri Ullas Sahab, who has taken us through the human to the learning and reasoning logic, the AGI, the types of brain, the chatbots, the history of the AI starting from 1941, and then also, I mean, sir has taken us to the hard drive, which was of a huge size in 1956, and to the laptops, to the palm tops of the day what we have today. And sir has also taken us to the smartphones, and then to the growth of data from small bytes to zettabytes. And he has considered that these bytes should not come in between the lunch bytes of the audience. So I'll be not taking much of the time, hurrying up to the stage of the vote of thanks today. And sir has also given us the applications, in terms of the oncological diagnostic aspects, how the AI tools are being used to diagnose a benign tumor or to a malignant tumor. Of course, the accuracy is up to certain extent, which is very high, barring 1% of the, you can say, misnomers or whatever you say, the false or pseudo diagnostic measures. Sir, I also highlighted the deep learning, the LLM models, and the deep blues, and use of AI in the chess competitions. Also in the driverless cars, how the AI is helping us. And sir has also highlighted the you can say the uses of AI in more than 150 areas, and also laid emphasis on the predictions in weather prediction, and you can say the early signs of diabetes or the heartbeats, or heart disease, how AI is helpful in preventive health of the individuals. Sir has also given more emphasis on the pitfalls as well. He has never spared those, that the ethical dilemma or the hallucination or the biases which may occur, or the security or the privacy concerns which AI is not in a position to take care of, and not meeting certain expectations of the human beings, and is of course not being equated to the brain of a human being, which is being generated by the Almighty. But still the science is on, the progress is on, the evolution of AI is on, and I am sure one day it's going to have the common sense as well, which was not there with AI. Sir, we are really thankful that from dendrites to axons rather, you have taken us today. And I, being not a very technical person, I'm from human resource management, I am so enlightened, so enriched today, and I'll definitely be dwelling on this particular knowledge, and enhance enhancing and try to come up to the expectations to learn the AI tools for the use of the benefit of the human beings. I'll also try to increase the number of the participants in the future courses of time, and when we have the sessions at the universities. And as our honorable chairman sir has kindly consented that yes, we can open a student chapter with the facilitation of our honorable dean at Susant University. I am really thankful to the lovely audience. With lot of patience and perseverance, they could pay their kind attention today. On Saturday morning we started, and we have come to now the afternoon. Sir, we are really grateful to every one of the members who have attended today. I am also grateful, greatly thankful to the people who have attended even from, you can say, Gujarat, also from Triple IT Lucknow, IIT Bangalore, and IIT this is what is, sorry, Kolkata. There's one person who is from Dr. Rakesh. He has attended from IIT BHU. There's one faculty who has attended from Thapar University. So they are very learned people, and we are really thankful with such a wide and varied experience that has enlightened everyone. Thank you so much. Once again, my hearty gratitude to Honorable Speaker and all the members who have made it a very successful event.
Professor
for providing
Rajendra,
the
10
holistic
out of
view.
10 for summarization. 10 out of 10.
Thank you, ma'am. Thank you so much. I stay
We
so
can, yeah.
interested, but of course,
Sahil,
I
you are
have
there,
I have
please, if you
slightly
can
missed
quick photograph.
Astron Institute for their facilitation today. In particular, Sahil ji, who has been always with us as a resource person in helping the technicalities in the Zoom meeting. Thank you so much.
Right. Thank you, everybody. Thank you so much.
Thank you, everyone.
Bye.
Really enjoyed the session.
Thank you.
Thanks a lot, sir.
Thank you so
Rajendra ji, thank you so much. And
welcome, sir.
all right. I already told you, and now that meeting is over, let me tell you, summary was so awesome. My God,
Sir.
I have to
Thank you,
learn
sir.
summarizing things from you. Because if somebody had missed the talk,
Okay.
then just by listening to your summary, they would readily, understand everything what was there and what brief or what topics were covered and so forth. But
Thank you, sir. Thank you so much, sir.
one mark deduction for missing out Astron.
Yeah, okay. Thank you, sir. Thank you so much. Ullas sir, thank you so much once again. Thank you, sir. And we look forward to receive your
Thank you,
campus
everyone.
of Susant University.
Really enjoyed the talk.
Thank you, sir.
Thank
you,
you.